Well, hi, and thanks for joining me here in my shop this morning. So this is the Canadian Westinghouse 535 I've been working on for the last couple of weeks, and it's in really good shape at this point. So I'm going to kind of push him off to the side here, literally, in favor of his big brother, which is sitting right here. There, we can take a look at both these radios at the same time here. So this is the 636, Canadian Westinghouse 636. This is in a floor standing tall cabinet. This is in a tabletop cabinet. This radio has 2 bands. This radio has 5 bands. This radio has a magic eye through the window there. This radio doesn't have a magic eye. This radio has off 5 presets for tuning AM radio, shortwave, and broadcast band. And this one has, I'm not sure yet, a lot more buttons. So it's probably on off, and then it's going to be probably 5. Let's guess 5 resets. 5 resets, and then 5 band buttons. 5. So that's probably what's happening. So you can see lots of other, general similarities. The layout is very similar on these 2 radios. They don't look that much different. Let's take a look at them from above. Now it might be a little tricky to get them both on camera here from above. By the way, the one I've just brought in was the radio I did my very popular arachnophobia radio video. This guy, and I haven't cleaned them, so all those spiders, spider carcasses, are still in this radio. If you notice a tube is missing, it's because that's the 6Q7 in the shielded can that I pulled out. My intention was to do something with it with the 535 radio. I never did. But that's okay, because opportunity exists in the future for everything. So tube lineup. You know what? Let's go back to the other camera here. Just keep comparing them right on top here now. Of course, the 636 has one more tube for sure. It has the I tube. Okay, so looking at the back of this, get them both on camera here. The similarity is really, really strong. Let's see. First of all, the chassis is bigger. 5 tuning, 6. Wait, 1, 2, 3. I can't count. 5 and 5. What's the antenna? No, the antenna connection is here. This would be where you could inject your phono signal to run your phono. This one's got a hole blasted in it here that I can see is an after cut. And this is the hole I'm sure that the power cord should come out of. Here it is here. There's the power cord is shot. No surprise in that. When we look at the 2 IF transformers, they are identical. See how this is a low one, this one has a higher top on it. Same thing here. They look very identical. It's the same tube lineup, I'm pretty sure. 6K8, 6K7. This is a 6Q7. This one should, oh, that ever come out of there easy. Holy smokes. 6F6 output tube. That'd come out of there so easily. Wow, it's just no grip. If I turn the radio upside down, this might fall right up. That's probably an issue. And then this is the rectifier tube here, 5Y4. So, for one of the few times I actually check to see if the right tubes are in the radio before I start. Of course, down the road I'll put the wrong tubes in, won't I? But that's okay. And we have the magic eye arrangement up in the front here, which of course is totally different. The magic eye, you can see the cable here with spider on it and rolling in there. You could practically buy a magic eye with its 5 wires coming out the back or whatever it is, and wire it into your radio. You could practically do that. The magic eye is really like just like a meter being applied to a certain spot. Okay, so the Magic Eye meter requires its own power, so you have to power it because it has a heater in it. But otherwise, the Magic Eye doesn't really influence the radio itself at all. You could take that Magic Eye and hook it up to this radio with a little bit of effort, and you'd have a Magic Eye on here. So I think that was an option that was easy to throw on top of an existing radio design. I guess that's what I'm really trying to say. So is there anything dramatically different here? Of course, there's no speaker sticking out here, but I see there's... No, there isn't. There's just no speaker sticking out here. Yeah, the transformers look very, very different in these two radios. Well, this one is sitting right up on top. And this one, yeah, I think that's the entire transformer there. Cycles, 60 watts, 70. 60 cycle. This one says cycle 25 or 60. And then the wattage is, this looks like 68, just about the same wattage. 25 or 60, and that probably explains the very different shape of the transformer. I'm going to guess at 60 cycles you can run a smaller transformer. I'm guessing that's the case. Physically smaller transformer. That would be why they would dump, well, plus 25 cycles was going away in power systems. Okay, so the tuning stuff is, we have an additional, okay, there's some changes here. Let's go back to the overhead camera here. Okay, so I can see 1, 2, 3, 4 tuning adjustments here, alignment adjustments, and they don't exist on the other radio. A little hard to see, but there's nothing in here. I like it. There's also this cover here. Which cover? I'm going to crank my camera up a little higher here. So there's this box here. The box doesn't appear on the other radio. It's just a open spot. The capacitor looks the same. The stringing arrangement's a little different on the front of the radio. How they've run the string. I'm not going to worry about that. I don't think there's too much else that's dramatically different up here. There's really nothing dramatically different. I mean, obviously it's got more bands, it's got more stuff. So before I open this up, I'm going to take the bottom off and we'll compare the two radios underneath. I'm going to get rid of all this dust and spiders and all that kind of stuff, and we'll have a much cleaner radio to work on from here. Okay, I got that all pretty cleaned up now. Man, piles of dust on this radio. I'm just getting ready to take off the bottom plate, and there's 4 screws along here. On the back there were 4 screws. Here's the 4 screws. As I was taking them out, I was saying to myself, if all these screws are in place, then maybe there's a chance nobody's ever taken this plate off since the day the radio was built. I flipped it around to the front and there's 2 screws missing. So what that tells me is, hey, I'm not the first guy to go here. Someone else has been here. So I might as well this will just take a second, so I might as well let the radio play. Also, the screws are not consistent. They're different screws. Different types of screws. So, great. Cleaned up pretty nice once all that huge carpet of dust was removed from it. One interesting observation here, well, it's not terribly interesting, but you can read there, it says 60 cycles only. Kapow! They put a stamp on it there, because probably what happened was they put these on the market and then some goofy people in a 25 cycle area bought it, took it home, and I don't know what it would do. Would it hum? I don't know what it would do. And so up came the stamp. From then on, pow, stamp it on there. It says right there, pretty bold too, 60. Oh, I like making up these stories about what happened. I have no clue. Okay, there's no side screws, so the plate, bottom plate's going to come off. These big brackets. Oh, wait a minute. Oh, this is the bottom plate here too. Where's the bottom plate from the other radio? Here it is. Okay, so this is for this radio over here. Yeah, you see the sides come up? Okay, I got more screws to get off here, and then I'll get the plate off. So a question we could ask at this time is, why only these two screws, or why were these two screws missing? And my guess is, when the last guy was working on this radio, he came up short for screws at the end of the job and decided to leave these two vacant because they're the hardest two to see. He left vacant. They're hidden in the front in the cabinet. He's hiding away the fact that he lost some screws. And maybe he was building his screw collection. Okay, how is this gonna come out of there pretty easy? I think so. Maybe I can just lift the radio right up and leave the leave the plate behind. Okay, by the capacitor and by the maybe get a better view of the disaster this way, I think. Okay, here we go. My computer's marveling at my feat of strength. There we go. There it is. Okay, anybody writing to us underneath? Oh, there once, sorry, I'm showing the wrong camera. There once was something on the bottom of this, but it's long gone. I guess that's what this is. This is probably a piece of it here. I'm guessing that's the sticker that talks about having a license, but I don't know. Okay, oops. Down she goes. Now, flipping this guy up on its side. My other radio, I had it up on bricks, but I've discovered since then, I discovered this morning, that in fact this thing can stand securely right on the face of its speaker. Everybody jumping up and down about what I just said? Right like that. Good enough. Okay, it's not bothering the speaker, believe it or not. It's fairly well balanced. So, intentional? No, I doubt it. Look at that, I even cleaned up the tubes in this radio already. Wow. Faceplate, I cleaned the faceplate because we're going to look at it a lot. Why look at a dirty one? Okay, so the best way to tip this guy up, clearly the wheel here extends past the bracket. There's no way you can tip it on this side without bricks and stuff. The heavy weight is here, so you kind of want this down. I think if I tip this up and just stand it on here, you know, it's going to be wobbly and it's going to want to fall over. Let's find out. Let's find out. It just has to be good enough for right now. Yeah, it's going to want to fall over, but I can put a block in here, a finger width block. I don't know, is that a little? It's a little too much. Just a little bit too much. Let's try that one. Still just a little bit too much. Every boy needs a good set of blocks. That's just not quite enough. There we are. I can stick something really thin under that corner there. It'll be solid as can be. It's a bit of a wedge. Well, maybe it's never going to be as solid as can be. For basic work, that's not going to fall over or anything like that. You're ready now. Here comes the big reveal. You watch my last videos. That's what you've been looking at. Drum roll. I haven't even looked under this yet. Here we go. Drum roll. That's a really crappy drum roll. Ta-da! Okay, so my eyes are snapping back and forth between these two radios. Let's get the same thing going on here. Okay, what's going on? So first, we'll look at this radio. And right away my eye is pulled straight to this resistor, which has got flaked material on it. It's a high wattage resistor. It's connected right to one of the filter capacitors. That guy looks like he's overheated. Doesn't mean it's bad. It just means it was getting hot. I see various colors of capacitors: green, red. This one here. They do not look original to me. So sure, somebody's been under here fiddling around. But I also see wax capacitor, great big wax capacitor. Appears to have been replaced once, resoldered here. Wax down here. Let's get the close-up camera going on these. Well, from a long range. From a long range. So now, is this plate missing from this radio? Doesn't look like it. The plate has screws here and here. There's no screw holes here. So probably the idea of this one is the bottom plate when you mount it on the radio. Oh my God! When you mount the bottom plate here, everything's going to change. Maybe all that alignment work I did was for nothing. Oh, no, it's never for nothing. It's never for nothing. So, well, that means if that's the case, if the bottom plate influences these coils, that won't be the case here as long as I have the plate on. The push button switch is just longer. And the on-off switch is right here, and it's right here too. Same place. The volume control is a more complicated one than the other. It has a inside shaft and an outside shaft, and two controls back here. And you know why that is? I know why that is. Why would they do that? Why would they make that change from this model to this model? On this model, the tone control is up here. Give a nice balanced look between the three knobs is probably what they were trying to do. Make it look nice, basically. But if you put the tone knob here on this radio, it's going to poke right through here. So they had to do something with the tone control. So rather than, I guess, stick it down here, it's probably not even possible. They really were stuck with no place to put it and make a nice looking radio. Nice balanced, you know, pleasing look on the front. So they incorporated it in here. And I'm going to go even further. This really doesn't look right. This looks new. This looks new. This looks newer than well, I wouldn't bet on that, frankly. It may look new, but I wouldn't bet that it is a replacement, because this all looks pretty original down here. But we'll look more closely at it in a moment. See, the power wire here is cracked beyond anything. It's cracked beyond. It's gone to the beyond is what it's done. Let's get it out of here. Here we are. That's my first real repair step there. What else do we see in here? How about impossible to get to capacitors? Well, again, there's a couple down under here that are pretty tough to get to, and I learned from the other radio how to do that. Capacitor installed with a long lead here, but it's okay. This radio had a very difficult spot in it down in here, where they put a terminal strip and then made heavy use of it down under here for hooking up components. This radio not so much. Here, it's here. They put it here. Oh, there's one there too on the other radio. So it's still, you know, great big capacitor here. It's got to go. There's another one down here. This is probably the tone one, if I remember right. I don't know. Now this radio does not have a speaker mounted to it, so it has a plug on the back. It has a locking screw too. So once you put the speaker in, which is just in another room here, I'm gonna have to fit it in the shop. It's a great big, I think it's a 12-incher. It's got to sit in here while I work on this, while I actually test and operate this radio. So, Brack brings up the question, do we dare turn this guy on as it is sitting here? Now, for me that decision is not so tough because I have a way of restricting the power coming in the radio, so it can turn on a dead short radio, like a radio with a short right in the power cord, and you'll still be okay with the way I do it. And of course, you leave things on for a short period, only a small amount of bad stuff can happen. So I have that option. Is there anything in here other than this resistor? Yeah, close-up camera. Didn't I threaten to use the close-up camera? Let's do that. Okay, let's switch to the close-up camera you see there, and we'll just scan this a little closer on camera. Okay, starting at that multi-volume control here. Hang on a second. Get a good look at my own big screen TV while I'm doing this. So there you can see the shielded wire. It's dead center. Uh-oh. Someone's just showing up here. Yes, Peanut. Peanut, you want to go on close-up camera? He wants me to leave the room, so he's not coming in. He's standing just outside the door, meowing at me. Okay, so let's just check these. How stiff are these wires? As usual, they are as stiff as can be. You know, when you have stiff wires, and then you find one that's not stiff, that's probably because the insulation is cracked somewhere, and that's where the flexibility is coming from. It's got tape on it here, but it's the same kind of wire here. So maybe the insulation cracked here, and somebody taped over it. So these are the leads, high voltage leads and whatnot coming from the transformer going to the rectifier tube down in there. You know what? This just looks a little weird here. Now that's probably the heater line. And you know, it looks to me like it's overheated. Heater line overheated. Not sure that's what that is. Where's it going? Of course, the rectifier has its own heater leads, but I think this is the general heater line into the radio. That's not good. You don't want to see any evidence of any of the wires overheating coming out of here, because if they're overheating coming out, they're overheating inside. There's a bit of a brush mark there. Let me get a pointer. Where did I see it? On here. I don't think it matters. Okay, so down the bottom there, way down in here, it looks like the bottom of the capacitor. Yeah, there it is up on top. He doesn't seem to be getting any extra help from any new capacitors or anything that's gone on in there. So I think there's more than one in this radio, isn't there? Now there's one here. Well, there's one here. Now in the last radio, this is done differently. If you look at the base, you see the metal can is just looks like it's riveted solid to the deck of the radio. And this one, where'd it go? Here it is. Same thing. But when you look at the other radio, you see these special brackets grabbing the can with a piece of cardboard in between the bracket and the can. And in fact, I don't know if you can see it under here, but even under here you can tell the can of these capacitors, which are no longer used by the way, is isolated away from the chassis. Those are important observations to make, he says, as he almost knocks these tubes onto the ground. So now this one up here, it's capable of being isolated in a sense, but it's not. This one is bolted right in. There's no isolation, unless the isolation disappeared at some point. Well, there would be a big terminal. No. Okay, not to worry. Yeah, that radio's finished, Jim. Don't go back there. Move forward. Moving forward. Okay, any funny surprises here? Not really. Oh, I missed this on the other radio when I was tuning it. It gives you the proper capable range of each one of these presets. Same thing on the back of this one, and I just didn't see it. Okay, let's not flip the radio now. Oh yeah, look, it's written right there. This is the other radio. I overlooked this. Although I had the idea in my head, I just didn't realize it was actually laid right out here. Very good. Hey, let's just read this sticker here too. 636X. Serial number 193. Really? They made 200,000 of these? So those numbers don't necessarily start at 0, of course. I wonder what AQV means. AQV. It's almost like the wine that's made in Ontario. It's got a nickname like that. Okay, let's keep looking underneath here. Let's check out these RF coils up here and see if any of these wires have been smashed off. Not likely. It's got a metal can, like it's got a cover on the bottom, so the chances are the only people who have done this kind of stuff are people like me, half-wit repair guys, I guess. Coming down from the capacitor. Tough go soldering that stuff onto the chassis. The other radio's done a lot better. Okay, we're going to get a look at that hot resistor here. So I believe this one, it's a big wattage resistor, so the designers knew this guy would be carrying heavy current. It's probably carrying all the B+, or most of the B+. That's one of the B+ filters there, I imagine. So that's why he worked hard. Doesn't mean it's bad. You see what it amounts to too? And correct me if I'm wrong. I'm often wrong. These resistors just basically a carbon rod with wire wrapped on either end, infused to the carbon somehow. It looks like solder in there. Somehow they try to make a good contact to the carbon rod. Bigger rod, longer rod, changes the wattage and the resistance. I think that's all this amounts to, really. Carbon rod. And of course then it's coated or covered in paper, which has come off. If that's paper, it's not paper, it's like paper. This could be some kind of like a paint sort of thing. Yeah, I don't think it's paper. Okay, well, what's the worst thing that can happen? The resistor is open circuit. They turn the radio on, it doesn't work because of this. The resistor, the radio's got problems and it sucks a pile of current through this resistor and it gets really hot really fast. I'm here to witness that. I don't think it's a risk. Do you see that lead sticking out dead center of the screen there? In most cases during factory, when they build these things in the factory, they would trim off that kind of stuff. Well, that's a hint that somebody did that afterwards, somebody like me. Not necessarily. There's another one. So not necessarily. Remember we had a lot of trouble with the buttons here. Let's. Whoa! That took a lot of strength. Oh, you can hear how gummed up it is, right? When I push this, I'm going to push that first button in again. Just listen when the second one releases. None of this sounds right, feels right. Really gooped up. Well, that's a little strange there. Not really. Looked at it with my own eyes. Looks ordinary. With my own eyes. And then it disappears under the can, not to appear again on the other side. That's the on-off switch we're looking at, and it's in a funny position because it's driven by this push button. Let's listen to that. Okay, the button didn't latch in the first time I pushed it. It's okay now. So the set should be off. Any other button should turn it on. I mean, I'm pushing with my little finger on this sharp thing. It's like stabbing your finger. So, you know, how hard am I pushing? If I had the proper buttons on, I'd push a lot harder. But this is painful. I really had to shove it there. So this switch is in trouble. Okay, for now, let's turn it off. That sounded really nice. Let's turn the volume down. Or is this the volume? Only time will tell on that. Power cord here. Ooh, yuck. So I eventually have to make another soldered connection onto here. Working with one hand only here. Just break it off. I'll have to clean that up a little better. We're going to make one connection there, another connection here. Let's pull this off. There we are. Ooh, loose wire. So this is where I'm going to put the AC 120 volts in. Hey, it sounds like I'm going to run this thing, doesn't it? Okay, so let me get it set up for that. I got to put the tubes back in. Or should I test the tubes first? Hey! No! Why would I do that? It would take some of the fun away. We don't want to do that. We're going to test the tubes essentially right in the radio. That's how we're going to do it. Now, just to show you, I can put these in the right way because I have another radio over here. That's a rectifier. Oh yeah, what was going on with this? What was going on with this tube? Which tube? 6F6. This one. It just fell into this socket like... Now, these two tubes are really interfering with each other. We'll start with the original, but I might quickly change this to a slightly smaller tube. These are the hottest tubes in the radio, and they're side by side here. And then, you know, they're roasting up the transformer, which has its own cooling problems. They've really packed all the heat here, you know, which might make sense if there was a cooling fan, but there never is, of course, on these radios. Okay. Next one would be a 6K7. That's the IF guy. See, this is great. I learned everything from the last radio. That means, you know, I'm going to have to make a whole new set of mistakes with this one. And the last one, we can safely assume this is the correct tube. I mean, it came out of here. There's no reason to think it's not. What's interesting, if you look underneath, you can see there's a metal tab right here that's wrapped over this pin. This is pin number 1. So this is the shield pin, we can call it that. And in the radio, this is probably just connected to the chassis by a wire. The way that connection makes it to here is through this. I guess it's designed to kind of bite into the pin here with these teeth and make a connection. Anyway, the other radio, no can on it, and I didn't realize it should have a can. I think it probably goes without saying that any 6Q7 in these older radios should have a can. A little top off. Pop them in. Oh my gosh, how am I going to get it in there? Really? This is hey, radio designers, what were you thinking here? Really, it's just I gotta bend the IF can out of the way here. That's not very good. And once I get it in these 3 tubes, and then you know what? And then the radio's sitting on them basically down here. Maybe that's why they're feeling so badly crammed. Actually, I'm trying to catch the transformer here. I think I was catching these tubes. Did that solve everything? Was it me all along? Oh, they're still really jammed together. Let me put the little hood cap on the tube. Give this radio every chance to work. I need a speaker. It's not going to work without the speaker. Okay, I got to run and grab it, bring it in, and figure out what I can do with this great big speaker. Okay, here we are. A gigantic speaker. Okay, so I'm holding it a little close to the camera to make it look bigger than it really is, but it's huge. It's a beauty. Look at that beautiful curve in there. Right? Perfect shape. Appears to be in perfect shape. Spidered up. Well, it's part of the arachnophobia radio, so it's got its own. It's got a huge amount of dust built up in there. That's the output transformer, and this is the field coil here. And that is the plug, and these are the wires. Wires are. You have a little bit of flexibility, but not much. So now normally, it's got to reach here. It's got to reach to here. My options here are pretty limited. How am I going to do this? Okay, so I'm going to spend some time figuring out how to put this speaker down. And what am I wearing on my sleeve here? This wire was just shoved in the back of the radio, so this was the replacement wire. The plug has been done wrong. I'm going to show you this. I've showed this before, but this is one of the few things I'm really pretty sure I know what I'm doing. So can you see the 2 wires come through? They kind of come up in the middle here, and then they go to the screws. And you might think, well, that's just fine, but it really isn't, because as you tug and pull and over the years go by, the wires begin to slide out from under the screw a little bit, and they're heading towards each other. They're heading towards a short circuit in there. So there is a better way to do this. I think I'm going to use this cord. So let's really loosen this up, and then I'll show you how this really should be done. Okay, pull them out. Yeah, these are in good shape. I don't think I need to cut them back or anything. Okay, shove them back in. So the whole trick here is to wrap around the pins. So you come at it this way. See, you wrap it around the pin. I got it back. You gotta get the screws out almost all the way. Tuck it under the wire, and this is another thing. I don't normally talk about this stuff, but everybody should know enough to put a wire under a screw in such a way that when you tighten down the screw, it pulls the wire under. If you do it the other way from what I'm doing, then when you tighten down the screw, it pushes the wire out from underneath. Okay, let's get the yellow one. Wrap it around the pin. That's why there's space here underneath the screw. And you might think, oh, is this really worth spending a lot of time on? Okay, so take a look at what's happening here. Get it into focus. And showing you a lousy image there. I'm sure you could follow what I was doing, but let's take a better look at it now, because something is coming up here that's worth looking at if I can get my camera to behave. So what I'm kind of drawing your attention to is this. These little bits of wire sticking out here. Out here. So as I wrap this under the screw, see how they're sticking out there? You ever wonder how people get shocks? So you leave these out here. Somebody's going to grab this plug and they're going to put their finger on that. I think you get the idea, right? So I mean, the plug can be great when it's first made, first put on. As the years go by, I'm going to trim those off after. Now often there's a cardboard cover that goes over top of this, which is another thing about making it safe. I'm just going to shove all that down in there. Shove down. Okay, let's tighten her up here. Down good and tight. Do the same with this one. It's worth it putting a little time into this. It's 120 volts right into your outlet. Do you really want to test it with your fingers? And pull on the cord to retract what's left of the wire. A very stiff wire. This doesn't exactly want to retract. A newer, softer wire would kind of sink in here. Uh-oh, ready to jab my hand. Don't do it like that. Now, when you pull on the wire, and of course you never should, but don't we all? I unplug my vacuum cleaner regularly by yanking on the cord, because we're all like that. If you yank on the cord, you're yanking on these connections. See now, if there's any looseness in the connection, the wire will be drawn back around the plug here, this way. They won't head together. You're much less likely to get a short circuit. Wow, that's about the longest time I've ever spent on just a plug of all things. And you know, that's a plug. That's a plug. It's a plug to... Hang on, everybody. This is actually nice wire. This is actually quite nice wire. Look what it says there. Heater cord. Can you see that? It says heater cord. Heater cord, it's probably rubber. It's going to maintain its flexibility. Heater cord. I have to prepare the other end. Okay, let me carry on here. I'm not even going to use this right now, for crying out loud. I'm just going to use it temporary. Okay, so I found a spot for the speaker to sit. Oh, maybe I didn't. Let's spin this guy right around. What do we want to be looking at when we turn it on? I'd rather be looking underneath it, actually. So most of these plugs do not have a locking screw. This one comes with a screw. Okay, if it wants to fit like that, it's fine. I'm going to put the screw in because if I don't, I won't know where it went later. So I'm not really intending on locking it in, but it's probably going to come out in and out a few times. But it'd be great if I could get this right onto this platform with the radio. So great, I'm going to try it. Fantastic. Don't think I want the shell of this to touch the chassis of that. It shouldn't matter, but I'm not ready to find out just yet if it does matter. So that's good, because now I can kind of swing the whole radio and it doesn't strain these wires. Check it's still stable. And if it falls over, it'll fall over slowly, so that's okay. Okay, cheater cord. I'm not recommending anybody do this. In fact, if you follow anything I'm doing in your own shop, your own life or whatever, that's your business. I easily do. I misspeak a lot while I'm in here. I intend to say one thing and something else comes out of my mouth, honestly, and I don't know it. You know, you watch, as I've mentioned before, you can watch newscasters have this happen regularly. And you can tell that they have no notion, they just misspoke, because in their own minds they said the right thing. And so I discovered this because I'm videoing myself all the time, and I do watch a little bit of my own videos, and I see myself doing this stuff. It's, you know, so I trust that you as a viewer can sort that out. You can figure out for yourself when I'm just misspeaking accidentally. Okay, just cleaning up these wires a little bit. Okay. So I mean, if you're going to follow, so it's up to you to maintain your own safety. I mean, you have to take responsibility for yourself. There are things I'm doing in the shop here to maintain my safety, and you know, it's a matter of odds. Frankly, you're going to do this work, you're going to get shocks. It's going to happen. It's going to happen when you least expect it, because that's when they happen. And if you've done the right thing, the shock will have a minor impact on you. It's a more embarrassment and a tiny amount of pain. But if you haven't done the right thing, you can throw your heart into fibrillation. We don't want that to happen. I have actually thought about, is there a chance I'm going to video my own death? I've honestly thought about that. I'll never know. I'll never know if that happens, so I stopped worrying about it. Okay, I'm just going to protect this connection a little bit. If you're talking about getting a shock, let me take a step here so I don't get a shock. Let me find my tape. Son of a gun. Try my best not to stop the video while I'm rummaging around here. Bear with me. Here's some tape. Okay, so this isn't electrical tape. I'm just trying to cover one of those connections there. Okay. Now, let's, so we want to be looking under here on account of if something's going to catch fire or be exciting, it's going to be underneath here. Just double checking. And you know, maybe this is the first of my videos you've ever watched. Starting on a new radio, I think sometimes people start watching. This is my my outlet here. It tells the voltage. You see it's blank. There's no power to this outlet. Look, it's just a regular 2-prong extension cord. The third prong on this isn't even plugged in. So if you see the third prong here, it means nothing. It's just sticking out in space down there. This leads via the power cable to a transformer, an isolation transformer. So there is no metallic connection directly from this outlet back to the Ontario power system. So that's part of what I'm doing. In other words, power being supplied to this radio is isolated by a transformer. But all that goes away the moment I start hooking up some equipment with grounds on it. The security, the safety of the isolation transformer goes away. So I'm just, you know, you got to read up on this stuff, get your head around it pretty good. Try not to get a shock. Try not to get a low impedance shock. Try not to touch the outlet. Try not. But the fact is, you will get shocks doing this work. I get about 1 to 2 a year. It's only caused a minimal amount of brain damage to this point. So, okay, talking about brain damage, let's turn this thing on. Wait a minute. Oh yeah, it's off, right? Switch is off, so nothing should happen. So just a further explanation of what's going on in my shop here. So I have lots of meters to look at up here. So this one is permanently showing the voltage coming into my house. It shows it here at about 119. This meter is plus or minus a couple volts. You have another similar meter here, which is showing 0. The scale on this meter only goes from 100 volts to 140. My buddy Scott built me this years ago. And so the idea is it spread the range right around standard line voltage of 120 up here. So this, when it's down like this, it doesn't mean 0. It just means under 100 or maybe 0. 0 is under 100, right? I have a control panel here with another meter on it. I hooked this meter up just for fun. This because it was there. This meter reads the percent of voltage arriving at the outlet. So if you have 120 volts and 80% is arriving at the outlet, you could calculate 80% of 120 is 102.9. Sure it is. But I just hooked this up for fun. So that's what this meter is doing. So 120 volts, this meter goes right over to the one here. Why did I do that? Like I said, it's just on here. And here I have a special tag. I got to show you this. This is a really important element in my shop. I don't think I've ever talked about it. Let's take a look at it though. Okay, so there's my switch panel here. I have a little light that'll come on. It's this thing here. Look at this. The ELFR eliminator. Isn't that something? Check that out. Electromagnetic something or other, something eliminator. I can't remember what ELFR stood for, but it's like electromagnetic waves, something like that. So you see, you get this sticker. You buy this. You can buy this. A Canadian invention. You buy the sticker. You get like 5 of them, I guess, and you stick them on your equipment, and just like that, there's no electromagnetic radiation, and you won't get brain cancer. Isn't that something? Okay, so, you know, this frog is about as effective at stopping electromagnetic radiation as this sticker. But one thing this frog won't do is ask you to send him money. These people who make this sticker, they ask for money for these things. Go on the internet. Type in ELFR eliminator. Read. Shame on those people. Shame on them. That's what I say. I say, shame. Canadian people. Okay. I think they're still in business. They probably have improved stickers by now. This came to me on a piece of equipment I was working on for somebody a few years ago. This was stuck on it, and I just peeled it off and kept it. Well, that poor woman, she's probably had brain cancer by now. I got her sticker. Okay, how's that? Now are we ready? Broke the tension? Let's build it up again. So what am I looking for? So I got two switches here. This one is a selector switch. This is the on-off switch. This is off right now. When it's on, a little light comes on. Can you even see it? Barely see it. Okay. But with this off, no power to this outlet. It's all about this outlet. This guy makes a selection between the power going straight to the outlet. This is off now. Straight up means straight to the outlet. So 120 volts will appear here, 120 volts into the radio, or whatever my line voltage is. But if I flip it down, now the electricity getting to the radio has to go through these light bulbs back here, these old incandescent light bulbs, which are nothing more than big resistors that glow when they're hot. So by forcing the current through these lights, they restrict the amount of power that makes it to the radio. It makes the radio and the light bulbs into a voltage divider. And only a portion of the 120 volts ends up at the radio, and the rest drops over the lights. The more on the lights, the brighter they are. This also kind of indicates the variation in the current draw on the radio during the warm-up stage. So when you first turn the power on through the lights, the heaters in the radio are cold and the resistance is very low, and there's a rush of current. I don't know how much, but it's significant. 2-3 times the normal amount of current, something like that. But within moments, the resistance is coming up. So you see the light literally down like that. Then it sits down here because the radio's not drawing too much power, because at this point none of the tubes are really operating yet, even though their heaters might be on. So after another few moments, the heater of the rectifier tube heats up and the rectifier tube starts working, and it begins to produce a high voltage of 300 volts DC, something like that, which is then applied to all the tube plates, and it begins to draw current through the tubes, and that additional current means the radio is actually pulling more current out of the outlet, more current through these light bulbs, so they get brighter again. So this is what it looks like. Okay, if you never watched this or watched dim bulbs, I'm going to tell you what to watch for when we turn on this radio. Because if it doesn't work this way, that's an indication right away there's trouble. So you turn it on, the light level should go up and come down, sit, and then go up, up, up. And at some point on the way up, we should start hearing crackling and stuff like that coming out of the speaker, and maybe we're going to hear sizzling, frying, we're going to see sparks, smell smoke. No, I'll smell the smoke and tell you about it. Oh, you want to watch those lights? I forgot a long explanation. I don't explain this stuff normally in my videos, and the reason is you'd hear it over and over and over and over and over in every video. So once in a while I'll go ahead and explain something, but most of the time I'm just blasting through the work. There's, of course, endless resources on the internet. Type in dim bulb system or dim bulb whatever and read up on it. So are we ready now? Did that build tension? Where's no antenna on the radio. And which one of you, we got to decide which button we want to push to turn it on. So so the way it is on the other radio, this is AM and this is short wave. Now this one has multiple short wave bands, so it's probably band 1, 2, 3, and 4, something like that. So these are probably all short wave, and this is probably AM. So when we go to actually have the switch hair trigger, did that not get pushed in? Bit of a hair trigger there. Okay, so when we go to operate the set, we'll push this button thinking it's AM. I could run out and look on the cabinet. Actually, you know what? It's on the buttons. And the buttons are the same as the other radio. They're just interesting little plastic blocks. You can put them in any order. So they're not going to tell me, but I'm pretty sure this is what this will be. It'll be the same. Of course. Famous last words. Okay, so we want the switch off. Nothing should happen. So I should turn the power on using the dim bulbs. Nothing should happen there. This meter should never change because it's just doing its own thing all the time. This one should pop up to 120, and this one should pop up to 100. And nothing should come on. No lights should come on. Nothing should happen with the radio. I mean, it's good to know if the off switch actually turns it off. Okay, so we all set here? There we go. We are armed and dangerous now. Okay, remember, nothing should happen. No lights. Don't put your hand in front of it here. I'll keep my hand on here. If something happens, I'll turn it off right away. There we go. Okay, all is normal. So this guy jumped way up, almost 130 on here, but it's not the most accurate meter, you know. So that's perfect. Nothing happened on the radio. Nothing happened on the radio. It's good. It's good. It's good. Power off. Switch on now. AM. Volume down. Just making sure down here. Volume turned down. Okay, everybody backing away a little bit. Okay, I'm planning my escape out of here. I'm reminding myself where the fire extinguisher is. Nah, I'm just kidding. I'm not that worried. But something's going to happen this time. So now, if there's a really bad problem, the lights are going to come on really bright, and I'm going to have to try to spot that because they come on pretty bright even if there isn't a problem. The cold heaters are going to draw a lot of current. So I got to kind of nervously hang on for a couple of seconds. If they're fully bright, I can probably recognize it right away. But when they're not quite fully bright, it's a little hard to tell. In fact, I'm going to even increase the restriction. Good idea, Jim. I'm going to undo this bulb. Okay, so the bulb on the right now isn't in the circuit. So now all the electricity is forced through this 25 watt light bulb. So there won't be much left for the radio. Okay. Radio test number 1. Should I do a countdown? Lights on. Now, because it's restricting the power so much, we're at 30% right now. It take a long time for those heaters to get enough current through them to warm up. So it's dimming down. I'm pretty sure it's dimming down. This is very hard to see on the camera, by the way, because the camera is not as good as your eyeball, that's for sure. It's dimming down a little further. Now, it's possible there's so little electricity getting to the radio that it's actually not going to rectify and produce any B+ voltage. So very unlikely to hear anything. I'm going to let it just sit like this for a moment longer. I could be doing tests on it right now, but you know, I like gambling a little bit here. So is apparently nothing bad happening. Apparently. So we're gonna increase and the voltage is 40% of 120, so that's like 35 volts getting here. Okay, how about 55? A little bit of bad arithmetic. That's probably just not enough, you know, just not enough. Okay, I'm going to cut the power, screw in the light bulb. This time it probably will get enough supply to come to life. So you really want to keep an eye on. Be able to see those meters up there and the light bulbs and everything. One thing you won't see is me running out the door, but you'll hear it. You'll hear that. Okay, here we go. 80%. Okay, and we're in serious business here. 97 volts, that's going to be probably enough to operate the radio. Volume up. Sound doth come forth. I'm trying to sort out right away which is volume and which is treble. That sounds like a tone. Yeah, that's volume. Okay, volume is full. This control's in a bit of trouble. When it hums like that, it's because my finger's touching it. I was going to say something else, but I can't because it's not true. So we're leaving the dim bulbs in. We're running still around 94 volts now. stick an antenna on it. What I do with all my wonderful cords here when I was cleaning up earlier. Just bear with me 1 second here. What gives? What gives? Come on. I must have taken. Oh, I put them over here. I put them where they're easier to find. That's kind of how that works, isn't it? Okay, so I got to put an antenna on it. We don't have to look at those dim bulbs so much anymore. You keep an eye on the radio for smoke. Smoke, especially up in this area. The watt draw on this radio is 32 watts. That's, you know, that makes sense at the lower operating voltage. 30. There we are, 94 volts still. I had a big ham radio day yesterday. We're going to have another big one today. Now I'm going to have to run and turn on the antenna here in the shop. So everybody practice counting to 13. Well, 13, just like I said. Okay, volume down. I got winded doing that. Just gonna hook up the center conductor. Hey, what did I just win? Did I win something? No. Volume up. Anybody surprised? I don't hear anything. Oh, this is really... Oh my gosh, look what somebody's done. They've tried to solder this piece back. Or it was soldered originally and it's come loose. That's a drag. Gotta fix that somehow. Come on, radio, how come you're not making any sounds? Okay, we'll do a little bit of experimenting here. It's possible 95 volts is just not enough. It's not terribly likely. Oh, I think I can see a problem. Okay, power off here. I never put the grid cap on. Any of these tubes. Duh. Special testing technique? No. That should make a difference. And there, fixed it. Okay. Ready to go again. Volume down before we get our ears blown off this time. Restricted power on. Light bulbs behaving normally. Okay, voltage at the radio is 97. That's with the volume turned down now. Boy, is that a good sign. That's a wonderful sign there. Volume up. Another good sign. Let's tune this puppy. So if we are on the AM band, we're going to find stuff down around here. Look at how nicely that cleaned up. Isn't that beautiful? Oh. Bingo! I don't know what would make it go so quiet right there. It's kind of odd, eh? It goes quiet like that. Hey, this radio repair stuff's getting easier all the time. why it goes quiet like that. This interesting question. Now, if it's a wild AVC voltage, or you know what, insufficient line voltage, do we dare put this guy on full? Let's just measure the temperature of that big honking resistor before we. Now that resistor may have fried, and then somebody fixed the radio afterwards. I touch it, but no. This is probably going to get my black cat in here in 2 minutes. 34. Now, when you're doing this with an instrument like this, you're just getting an average of everything the instrument can see. So, you know, if this thing showed a 50 in here, I would jump up and down, but it's showing nothing. I don't smell anything. Who'd have believed, that this spider-ridden dust bucket of a radio would work if you just plug it in and turn it on. Not saying it's working well.
Business owner, you've had an experience. We'd love to hear right now than calls. I think a lot of people.
It strikes me there is something weird going on with the AVC. Well, let's give it the works. We'll give it full voltage here. Where's my escape route? Okay, ready. So what's happening is, I'm going to put the power back down, as I tune in the station, the station signals coming through the IF are getting detected and rectified and producing a bias voltage, AVC voltage, to shove back through the front of the radio. It takes time for that voltage to build. There's a capacitor and other stuff purposefully designed to make sure the AVC voltage doesn't react immediately. Okay, so we tune in the station. The AVC voltage is rectified or created in the detector tube, and at first it's big. No, at first it's small. But given a fraction of a second, it builds up. So while it's small, there's no restriction, there's no volume control, automatic volume control in the radio. The radio's loud, but then as the AVC builds up, it goes down. Okay, see if I can. Usually after explaining things like this, I then prove myself completely wrong. So let's see if that happens here. Well, I don't hear that effect at all. Oh, you know what? We're back on restricted. Now, the radio appears to be in cutoff. I'm guessing grid bias has reached a point where a tube is cut right off. Come into it loud and quiet. There, that seemed to really show it. And look. I think it's the AVC voltage, I can't be sure. But it's an interesting effect. It's definitely a problem. It needs to be sorted out and understood and solved. Wow, okay, so I'm way ahead of where I thought it would be. Got a radio that works. That's way ahead. That's way ahead right there, and that's also a happy day. Look at, I just want to get this monstrous speaker pounding out the sound here. The cabinet that came with this radio is seriously damaged. on the front of it where the knobs come through, there's a crack, and the wood is shaped, it's bent, and it's cracked, and it's flaked up. It's got a serious problems on the cabinet. Otherwise, I think it's a pretty cool looking radio. So if I can solve the problem on the cabinet to the point where it looks okay, then this is a real winner. This will be a real winner of a radio. Fantastic. Okay, that's a great day. It's a good time for me to stop. I'm going to have a great day. I'm going to be doing FT8 on my ham radio today. I spent yesterday getting it all set up and working properly to do FT8. That's the latest digital mode on ham radio. I won't go into all about it. If you're a ham guy, you probably know about it. I'm just catching up. The world of ham radio operators is going nuts over this technique for communicating on ham radio. FT8. Okay, see you on the next video.